Hi, hello friends, welcome to my YouTube channel. Now in this session, we will continue our discussion on Tsgenco AE 2015 electrical solutions. Right, the question that here we'll begin with is, in a DC machine, the interpoles are used too. So in a DC machine, okay, so when we are having the interpole region between two poles like this, so this is the interpole region between two poles. The region is called interpole region. So we will place here a interpole magnet here. So a small magnet, interpole magnet here. So which is used to neutralize the effect of armature reaction. Why? So here we have leading pole tip, here you have trailing pole tip. So because of these tips and saturation effect of this core, the flux is not uniformly here distributed here. So here we'll have some maximum flux here. So in order to neutralize this flux, we will use the interpoles here to neutralize the armature reaction effect here. So the neutralize effect of armature reaction in the interpole region is the right answer. And it's another simple question from the DC machines. The function of brush and commutator arrangement in a DC motor. So when you are going to discuss about commutator here, so commutator, suppose which is connected here. So this commutator here we have, suppose armature here, and this is a commutator here. So commutator, what it will do is it will convert the DC quantity into a AC quantity in motors, that is DC motors. It will act as a mechanical inverter. So mechanical inverter, so which will convert the DC quantity, that is a unidirectional flux or unidirectional current, into a alternating or pulsating quantity here. So which will makes or produces the torque, unidirectional torque in a machine. So the answer is produces unidirectional torque in a machine here. Okay, so without this, the commutator, the machine will act as a AC machine. Right. So next question. Next question, it's a very simple question here again from machines. Aluminum is not used as a winding for the armature of a DC machine because normally the reasons are here. Aluminum has a low resistivity is wrong. So aluminum resistivity. So our aluminum is greater than our copper. Okay. So larger winding space is taken by aluminum conductors and create jointing problems. So when you're winding the aluminum wires, so it will create some jointing problems. That means it will have less mechanical strength compared to copper. There's a reason, true reason. And second one is the thermal conductivity of aluminum is low. So this one also true. Suppose if you are operating the aluminum at higher temperatures, it is going to be melt down. Okay, so melt down. These are the two reasons. Aluminum has a low conductivity, it's a wrong option. So among these two options are correct options. If you have given any one answer from the two or three, you will get marks here. Okay, next question. The next question here is the induced EMF in armature of a lap wound 4-pole DC machine having 100 armature conductors rotating at a 600 RPM with 1 Weber's flux per pole is. So the basic fundamental formula for this one is E is equal to, yes, you know already this one, 5Z NP by 60 into A. So for lap connected winding, that is armature conductors or parallel paths, is equal to number of poles. So the formula again reduce it to 5Z N divided by 60. So what is the 5 they have given? 1. Number of conductors is 100 into N is how much the speed is rotating? 600 divided by, again you are having 60. So 1, 10, so 1000 volts is the answer for this question. It's a very simple and straightforward question here. Next question. The next question is a 400 volts 50 Hz 3-phase induction motor rotates at a 1440 RPM on full load. The motor wound for. So in the given problem, we will use two formulas. The first one is Ns is equal to 120 F by P. Another formula is, so Ns is equal to Nr divided by 1 minus S. Generally, the induction machines slip is in the range of 4%. So based on this assumption only, we will going to solve this problem here. So Ns is how much? Ns is equal to Nr is nothing but 1440 divided by 1 minus, so S is 4%, so 4. Okay, so 4% means 0.04. So it is nothing but 1440 divided by, so 0.96. So we'll get it as 1500 RPM. So once we got this synchronous speed, then we can find the number of poles. So Ns is how much? 1500 is equal to 120. So 120 F. So F by P. So which is nothing but 120 into frequency is 50 divided by P. So you will get it as 4 poles. So answer is 4 poles here. So assumption here is the slip is 4% here. So this is we have to assume in order to solve this problem. Thank you friends. Have a nice day.